Okay, so question 8 of the Junior Cert Maths Higher Level 2023, Part A. Convert 7.5 kilometers to meters. So there's 1,000 kilometers, 1,000 meters in a kilometer. So that's going to be 7,500 meters. So that's your answer for that part. Part B, plane P, so it's not, there it is, took off from an airport. It left the ground at T. After a few minutes, it was 7.5 kilometers or 7,500 from T, and it was 200 meters directly above ground level as shown. Diagram not to scale. Use trig to work out the size of the angle marked E in the diagram. Give your answer to a number of decimal places. Okay, so we've got a right angle triangle here. So this here is the opposite of E, the angle E, and this here is the hypotenuse. Okay, so I'm going to also just set this to be 7,500. Okay, so opposite over hypotenuse, if you go to your log tables, they're all here for you. So opposite over hypotenuse, this is angle A, or E in my case, that's A over C. So A over C here, you'll see, is sine. So that's the one we're going to use. So sine of E is equal to opposite over hypotenuse, which is 200 all over 7,500. I want to work out what E is. So to do that, I need to get the inverse sine of this part. So I say E is equal to sine inverse of all of this. Okay, and I can crank that directly into the calculator. So I want to say shift sine inverse 200 all over 7,500 and close my bracket. I get 1.528. What's after that? Okay, 0 to 1, correct to 1 decimal place. Okay, so I'm going to leave that at 1.5 degrees. Okay, now it doesn't look like 1.5 degrees, but I want to draw your attention to this statement that they made. It's not to scale. So I wouldn't worry about the fact that it doesn't look like 1.5 degrees. This is a very long amount of distance here, 7.5 kilometers. And they're still only 200 meters above the ground. So that's probably accurate. Okay. Right, so that's part B. Part C, write 20 minutes as a fraction of an hour. Give it in the simplest form. Okay, so that's 20 over 60 minutes. Take off your 2 zeros and divide both sides by 2. You're going to get 1/3. So that's 1 over 3. So it's 1/3 of an hour. All right, so that's all you need to do for that one. Second part, during its flight, plane P traveled this amount in 2 hours and 20 minutes. Now, see the way it's 20 minutes here as well? They want you to use what you've just calculated, I would say, to work out the next part. Work out the average speed of P during that time in kilometers per hour. Give it to 1 decimal place. Okay, right. So the first thing we write down is the speed. So you'll remember from your maths chapters, speed is equal to distance over time. So we have the time and we have the distance here. So this is d, and this here is the time. Okay, so the distance is 598 and the time is 2 hours plus 1/3 of an hour. Okay, I'm going to crank that directly into the calculator. So I'm going to say 598 all over 2 plus 1/3. third. Keep my accuracy. Okay, if I said 2.3, I'd be losing some accuracy. So now that's 256 point, what have we got there? 285 to one decimal place. Okay, so I'm going to set that to be 256.3. And what is it? Kilometers per hour. Okay, so that's part 2 of that. Keep going. In the diagram below, each of the points A, B, and C represents an airport. Okay, so we've got 3 airports. Plane traveled this far to B and traveled on to part C. So we don't know if that distance is there, but maybe we don't need to. Right, so work out distance from here to here. This is the one we're interested in. Okay, they're after highlighting here that this is 90 degrees, so that's important. Okay, so what do we need to do? Well, we need to work out this part and this part. There's 2 little pieces to it, right? So that's why that dotted line is there, I would say. So because this is a right angle and I have that distance and I have this distance, I can use the Pythagoras to work out part 1. So part 1 is PHY. I might have spelled that wrong, Pythagoras. And part 2 then, I've got an angle and a side, so I should be able to work out the other side. So this part I will solve with trig. Okay, you can go to your log tables. This is Pythagoras here, so c squared is equal to a squared plus b squared. So here I've got this one and this one. So this is c, and that is either a or b, and that's the other one. So it's basically 580 squared is equal to 280 squared plus x squared. Right, so 5 2b squared is a big number. 357,604. 280 squared is 78400 plus x squared. Right, so I'm just going to flip the order around here. So x squared is equal to this one subtracted the other one. So x squared is equal to, so 357,604 minus the answer, which is 279,204. So x is the square root of that. So if I say square root of my answer, I get 528 point what? 397. Okay, so that's part 1. So I need to add these together at the end. Now for the trig part, I have this distance here, so this is my angle, and the opposite side is what I have. I need this one, number 2, so if you go back to your log tables, so I have this one here, and I need b. I have a and I need b. I don't care about the hypotenuse. So a over b is the tan function here. That's the one I need to use. Okay. So the tan of 35 degrees is equal to a over b. In my case, that is let me just check that again. Opposite over adjacent. So this one here is the adjacent. So it's 280 all over x. So now I'm going to cross multiply. So I'll have x tan of 35 is equal to 280 So divide across by tan of 35 to give me x equals 280 all over tan of 35. So let's see what we get with that. So 280 tan of 35 is 399.8814. Okay, and now I will add that to 528.3975. So my total distance then is to the nearest kilometer, so that's going to be 928. So I'm going to write that down. So 1 plus 2 is equal to 928.278.9. So I'm going to be 928 kilometers away from A to C. Okay, so that's your answer, and that's it for question 8.